Hello, my name is Darwin Sonoy. I'm a Staff Solutions Architect in GitLab's Alliance Partners team. Wanted to talk to you a little bit about integrating GitLab with AWS. Specifically, we're going to go through a little bit about why you might want to do this and about the many ways that you can go about actually doing the integration. So let's dive right in. So I want to talk through just a couple things about GitLab value added. We're going to be diving into more technical details about how to integrate GitLab and some of the benefits of doing so. But there's some vast areas of the product that would be really hard to cover in a short period of time. So I just want to emphasize those characteristics that are value added. So one of the first things to know is that it has industry-leading code change controls with collaboration. So this is the capability to discuss code, talk about code, have change controls that prevent code from being merged when it's not ready yet. There's a lot of richness in this part of GitLab that is something that it adds value to the AWS story. In addition, dynamic review environments and applications per feature branch. So when you deploy GitLab in certain ways, especially if you're using Kubernetes, but also if you're using Nginx or other web servers, every developer feature branch can have its own review environment associated. And every time the developer pushes commits, that review environment is updated. So this is an important differentiator. It's also important to understand that that means that CI is not waiting for merge approvals on feature branches. It just goes ahead and runs every time. A third one that's really important is shifting security hard left. And what this means is that developers see vulnerabilities as just another build bug at build time. When they're going through and running their builds, instead of having all their work done and then doing security scanning and disturbing a lot of integration work and solution work that's been done, instead, the very first time they run a build, if there's findings that are relevant that they have just introduced, those are presented to them immediately. And so this is a huge benefit, is getting the security story to be as far left as it possibly can be. Then advanced deployment controls with change set collaboration. So you'll notice the collaboration theme comes up again and again. In fact, I didn't highlight that within our security capabilities, collaboration around findings is a normal thing. And if you've done collaboration around security findings in the past, it can be one of the most arduous, complex, and confusing parts of the whole process because you're working off spreadsheets or documents or hopefully not, but email chains that go on and on and on about a single finding. So that collaboration capability is also preserved in security. It also comes forward to deployment controls. So GitLab embraces GitOps, which means using your source control management system's controls and the concept of merging to control moving to new environments and promoting between environments. So all of the collaboration that might happen in an operational type situation with deployment can also happen around merge requests and issues like it does for the rest of our code. And then finally, DevOps transformation enablement through templating and auto DevOps. So this is the capability for you to give your teams ready to use templates or even potentially auto DevOps to improve their productivity when onboarding to CI and CD. It's very possible that if they have a well-expressed project in a language framework like Node.js or Python, that Auto DevOps can actually do absolutely everything for them. And this also allows you to set up your own templating and expose that throughout the system. So if you are working in a large organization of developers and you want to make sure that they do things the way that your company wants them to do, then that is one of the capabilities that you can extend, is giving template projects and template CI files. In addition, we can also support Kubernetes very strongly through this. Auto DevOps is oriented towards Kubernetes, but even if you have your own way of doing Kubernetes, then that cloud native transformation can also be facilitated by GitLab. GitLab is very comfortable with Kubernetes, even lets you create EKS clusters in the UI. And another one is development of DevOps value stream analytics. So once we start getting all of the information about the entire lifecycle of applications inside of GitLab, we can start to see what it actually takes and what our average throughput is for taking an idea and getting it into production as an experiment or a productionized capability. So that visibility and that ability to prove the value of your DevOps setup is one of the big perks that GitLab brings to the table in terms of adding value to your AWS deployments. So we're going to walk through some details about the controls that we have in GitLab for gating controls and GitOps. In addition, collaboration. We won't actually touch that deeply on collaboration as we go through this, but all the collaborative capabilities of GitLab itself are also in view here. We typically think of grabbing a branch to start our development activities on as an individual developer. Then as we bring that branch into the shared system, we are going to merge it into some sort of shared branch. Now, GitLab has a lot of controls right at that point as far as your code, what can be allowed in. The push rules are one of those specific controls, and push rules prevent a lot of bad things from getting pushed to the main repository. We also have something called signed commits and verified committers, and this allows you to ensure that whoever the commit says created the code did indeed commit it, and also that the commit has not been tampered with since they made it on whichever machine or editing environment that they work in. We also have something called locked files and directories, which allows individual developers to say, no one else is allowed to work on this file or this directory on any other branch while I'm working on it. From your feature branch, we also do CI. So this is a unique thing about GitLab. GitLab allows you to do CI on ephemeral dynamic developer branches. So when a developer creates a branch, unless you otherwise specify, GitLab is going to run CI on that automatically. When you run CI, you can also run CD. And another interesting part of GitLab is that we have something called dynamic review environments. And what that allows you to do is, even on this developer branch, set up an environment for your application, and you can do all kinds of interesting things with it after that. You can do your typical user-oriented human testing, but we can also do all kinds of scanning and testing, including SAST testing. Also, in the CI/CD, we will run the security testing on every developer branch every time commits are pushed. Then as we move to integrate our code into this shared branch, we have some controls. First of all, code review. There are a ton of code review type controls. I'm not even touching on all of them here, but branch protections and tag protections are examples of some of the capabilities that we can control at that point. We also have merge approvals, and this is a very rich featured thing inside of GitLab. You can have all kinds of controls around who's allowed to merge code, do builds have to pass, can the person who is the person who created the commits, or created any of the commits in the merge, allowed to approve their own commits? Is the person who created the merge request allowed to approve the merge request? So you can have all kinds of controls that are important to ensuring the quality of the code and that those who are reviewing it have the best perspective in terms of reviewing the code. We then, of course, can do CI/CD on these shared branches. And now we can get a little more in depth because we understand that this is where we start to see the system coming together. Maybe 5, 10, 20, 100 feature branches are coming together depending on the next release and what it's going to contain. And so we can run CI/CD to make sure that the software builds properly, deploys properly, and that there's no security problems that are caused by unforeseen merging of branches creating actual security issues. Now, importantly, we also have an additional control in GitLab, which is deployment gating. So for protected environments, we can have additional controls onto who can actually deploy to that environment. And so environments is a concept that runs throughout GitLab. GitLab uses it in a lot of its automatic functionality, such as Auto DevOps, but you can tap into the environments metaphor throughout the entire system and create environments in almost any target deployment architecture that you want to. Next, we're going to make a move to merge this code forward. So because GitLab works in GitOps, we now use Git-based controls to do our operational management in terms of change management, as well as actual deployment of software. So instead of now at this point handing off to a deployment system, we merge forward to a new branch. With GitLab, you have merge approval gates and branch protections that are branch specific. This means that these particular items are not the same for the entire repository. It's branch specific. You can see that we are also doing our CI/CD here, but now I'm depicting that we can deploy to Amazon type application architectures. There's a variety of ways of doing this. Some are supported very natively, such as Amplify. Amplify is one of the newer Amazon application architectures, and so it has built-in capability to link up to GitLab for deploy. We can also hand off to other intermediaries, such as Code Deploy, and we also have native Kubernetes capability built into GitLab. If we don't have quite the one that you use, you can easily craft something to link this up. This same approach will then be repeated throughout additional environments. So as we promote between environments, we merge to branches. Those branches target the final deployment environment, and we're able to have very granular controls over who can deploy where. Also want to note, it's very common for many of our customers to use Terraform to deploy to Amazon, and we do have support for Terraform in two ways. There's integrated support, so GitLab can be a state store. Terraform can run inside of containers, and in some ways GitLab gives you some of the advantages of a Terraform type service, or you could potentially be integrating with Terraform Enterprise if you have either stood that up or purchased it as a service. So many ways to consume Terraform and all of its cloud benefits. Now let's just take a look at how you can integrate with Amazon. We're going to roll back a little bit and talk a little bit about the Amazon CodeStar type utilities. So CodeStar is a system for deploying and building software and deploying it to your environments. And some organizations have this in place and they want to integrate with it, or you may have just certain teams that have it in place and want to integrate with it. Code Build and Code Pipeline are able to create specific pipelines. It's important to know that these pipelines are per branch, so they are set up on each branch you want to deploy to. So the dynamic review environment's capability is a little harder to try to recreate inside of this. In addition, there's a lot of pipeline components. If you see across the top of the screen, the S3, CloudWatch, CloudFormation, IAM, a lot of these elements are not automatically created by source files that are inside of your repository. So GitLab has a GitLab CI YAML file, which is really pipeline as code. And you define everything about your pipelines for all your branches inside of that file, and it automatically handles that. With CodeStar, you're either going to have to create your own enablement automation to deploy this kind of infrastructure, or allow your developers to go into CodeStar and say, create a new branch. When they create a new branch, create a new pipeline, they are going to create individual sets of all of these different things you see at the top of the screen for each branch. If you want to engineer it so that, say, a given team reuses the same, CloudWatch, CloudFormation, IAM rules for all of their pipelines, then you need to set up some automation to be able to pre-deploy that with CloudFormation or something else. So this is the typical flow. Notice that some folks are not aware that Code Pipeline can be triggered by an S3 artifact arriving. So it can monitor S3 to see if an artifact arrives, and then if an artifact arrives, to go ahead and start processing a pipeline. Also, the Elastic Container Registry. So we can, upon the push of a new container to a certain registry, kick off Code Pipeline. And then code commit can kick off a code pipeline. Now, one thing we're going to cover here is a lot of folks ask us, well, hey, I see that when I fire up code pipeline, I can integrate with code commit and a couple other third-party SCM tools, but I don't see GitLab there. And so one thing we'll talk about is if you do need to have code pipeline in place, how do you get into the front end of that funnel? But we'll also talk about other ways to get into this funnel and some ways to move more towards GitLab native environment. So let's look at adding GitLab to the mix here. Now, GitLab is a full SDLC DevOps tool that allows you to manage everything from agile work management all the way through to production and deployment monitoring, and also defending or security. When we have GitLab source code management and we commit code to it, we generally go through a merge request to go to any branch other than a feature development branch. And from there, it proceeds into GitLab CI. Now, when we have a feature branch that a developer is working on by themselves, we do skip the merge request capability. And sometimes people don't understand this, but skipping that merge request is important so that the developer can deploy and run scans, because they're really pre-merge scans. In any case, we go through the GitLab CI job stream, which is controlled by the GitLab CI YAML file. And this file is notably pipeline as code, which means that it is developers changing that code right inside of that file is what controls all of the pipeline. Notice that we can process multiple branches in here. Now, by default, every branch would go through all jobs every time, unless otherwise specified. In this case, we can handle multiple branches by having different jobs. So you might have one job that only applies to, say, the default branch or to certain special branches, and you can call that out. But we're not required to create a different pipeline or a different pipeline file or any kind of infrastructure setup in order to service as many branches as we want in our repository. GitLab then also can deploy these dynamic review environments. Dynamic review environments are their own kind of feature, but they also go along with security scanning for DAST scanning. Now, security scanning is also its own feature. For all the non-DAST scanning, you can do that scanning without the dynamic review environments. But for DAST and for fuzz, we need an actual standing instance of the application, and that's where dynamic review environments come in. These dynamic review environments are also set up on every developer feature branch so that they are automatically available, and they're automatically deployed as well seamlessly when the developer creates a new feature branch and starts working on it. That capability, dynamic review environments, and the security scanning that requires an actual running instance of the application kind of go together. Then from this, we can start adding additional triggers to our GitLab CI jobs. So we can deposit S3 artifacts, which is a trigger for code pipeline. We can also push containers to ECR, which is also a trigger for code pipeline. So sometimes when folks are asking this question, how do I integrate with code pipeline? They're not necessarily thinking about the fact that maybe the result of their current code pipeline is a container, and that's really what they're deploying. So in that case, GitLab could generate the container and simply drop it off and have code pipeline go through the rest of the way. Same with S3 bucket artifacts. Another way, though, that is now in our documentation but has not been in the past is repository push mirroring. So for GitLab Premium and higher, you can configure push mirroring, which allows you to say, hey, anytime I get commits to this GitLab repository, push them forward into code commit. So this is another method of integration. In this case, maybe you're using the GitLab CI capability just for dynamic review environments, but when it's time to push to that next production branch, well, then you're going to send it straight to code pipeline. Another way, though, is to have GitLab directly integrated to deploy. So you want to take a look at your code pipeline and understand if the steps you have in there are actually essential to getting the deployment piece done. So code build typically will build your code and then deploy it, but it's very likely that there's some overlap in terms of what builds could be done within GitLab, and then take advantage of some of the advantages that we've been talking about. In addition to dropping directly into code deploy, which is a frequent output on code build pipelines, we can also accommodate these other infrastructures. We directly accommodate ECS and EC2 in terms of some auto deploy capabilities. Amplify has GitLab as one of the options that you can wire in for deployment natively. And then some of these other infrastructures can be serviced indirectly by code deploy. So Lambda, ECS and EC2 can also be done by code deploy. And then if you have anything else, you can really just use the CLI from that particular service in order to deploy to it. So Elastic Beanstalk is an example of something that's not directly integrated to, but you can simply use a container with the Elastic Beanstalk CLI in it in order to trigger those deployments. So lots of ways to integrate. In addition, there are many ways to use Terraform inside of GitLab. So one way is completely integrated. GitLab has its own Terraform state store capabilities, and so you can use the local Terraform CLI within a GitLab container in order to do those deployments and store state in GitLab. You can also obviously integrate it with Terraform Enterprise, whether you have an on-prem or a SaaS subscription. Code build is based on container-based builds. GitLab can do container-based builds, and that's kind of the native, most observed way that it's done. But it can also do all kinds of other runtime environments on the runner, such as shells, alternate operating systems, and other things. But when you're looking at doing containers and porting a container-based system into GitLab, it's really quite simple of using a similar container to what is used on Amazon to build that, say the Node.js container to do Node.js builds. And then you can bring more of the build activity into GitLab. And that benefits you in having more flexibility, having that pipeline as code capability, having those approval capabilities all in front of your actual build activities. So some of the significant and unique capabilities, the velocity of feature development, especially with DevSecOps, so getting that capability of being able to add new pipelines, new branches, dynamic builds for all branches. Build as code, or what I've been calling pipeline as code, kind of more self-service for developers. They can change that file. We also discussed briefly how pipeline development becomes just another developer activity. So a developer will create a new branch and only be dealing with how to fix the CI or enhance it for future needs. And so pipeline as code is not a small thing, and it shouldn't be overlooked when you're considering what to do. Also, multi-branch and any branch pipelines are automatic and the norm. Automatic dynamic review environments, which we've touched on. Security scanning and merge requests, so making security vulnerabilities just another bug. And then GitOps using GitLab for deployment. So let's chat a little bit about some resources that will help you with your work in this area. So first of all, we have the GitLab AutoDevOps to EKS. So when you look at AutoDevOps and its capability to deploy to Kubernetes, EKS is fully supported. Also, you might find that we are able to deploy EKS clusters from within the UI of GitLab. That's another interesting integration that can help your developers get started with EKS in a more simple format. In addition, we have information about deploying with our auto deploy capability to ECS and EC2. And finally, the documentation on how to push mirror a GitLab repository into a code commit repository if you really need some critical capabilities of code pipeline. I also just wanted to note that I'm a solutions architect and work in our sales area. And so if you have any challenges or questions about getting started with getting GitLab working with your AWS setup, feel free to contact our sales organization. And you can also see all of my handles there for social and blogging on the screen. It's my hope that what we've covered today will help you understand how and why to integrate GitLab with AWS.